Reload this. Close this. Close that. Extra computer. Great. Hello. Okay. All right, let's get started. Hope everybody got a good weekend. So a couple of announcements to make. So quiz 3 is due on Friday. Don't forget about that. We're not going to have like sub quizzes anymore. And assignment 1 is due next Friday, 9 p.m. And we have help sessions starting from this week. So we have help sessions this week. We have help sessions next week. I think most of them are in person. So if you got a assignment related problem, you can go there and the tutors may be able to help you with your setup. Maybe they can give you some pointers, but they can't really give you the answer, obviously. And one thing about using the forum is that we have set it up 2 sections for assignment 1. For assignment 1, we got the assignment 1 general as well as private. So if you want to ask like clarification questions, like what does it mean, like I cannot find my files, things like that, and you don't want to share your code, then you can go into the general stream. And if you want to kind of include your code and ask tutors to give you some pointers, obviously you cannot share your code with other students. I think that's a given. So to use the forum, you need to post that in the private section where only you and the staff members will be able to see your code, and hopefully they could help you. Okay. And help sessions done, assignment quizzes, what else? That's it. Let's get back to PLPG SQL. So last week we started talking about PLPG SQL functions. So today we're going to talk more about how to use these functions, how to write these functions, important syntax, important nuances, as well as procedures. So we'll learn more about procedures on Thursday, where we'll talk about procedures and triggers and things like that. So this is how you can define a function, obviously, in PLPG SQL. You need to create or replace a function, and then you need to declare the function name. This is how you can declare the variable names, and you can write your function body between beginning and end. And you need to specify that the language is PLPG SQL. And a couple of things I need to clarify. So last week, a student, I think you asked me the question, why are some variables underscored? Why are some variables not underscored? So you can use either one. If you make the input parameters not underscored or underscored, that's completely fine. But the convention is that the parameters get underscored, and then the local variables are not underscored. So that by following that convention, by looking at your code, you know which part is from the input parameter and which part is like some local variables you want to use for computation. So that's just a convention that is highly recommended that you follow that convention. So that's the difference between those two. And we should look at if we can do some demonstrations. So far we have looked at how to declare local variables, and you have learned basic control structures. You can use if, else, a for loop, and a while loop if things get more messier. And we have briefly talked about the couple of return types. So obviously, you can return a single integer, can return a single string. But functions work like parameterized views, right? So functions are for query purpose. We want to get something, we want to read something from the database. So remember when we're doing the view, we're returning a table, or we're returning a column, or we're returning some values. And we want to do the same in functions as well. So in functions, we also want to be able to return a set of values or a column of values. So we can use, in that regard, we can either return a whole SQL query, or we can use a for loop to go through each row of the query, apply some processing, and then build up the result set using return next, and in the end, return the whole thing. So I think it makes more sense if we do a demonstration. And after that, we're going to talk about how to store some query results using select into, and how to handle missing data, and how to do dynamic queries, and how to do error handling, as well as how to do debug. Let's look at this example. So this is like probably the easiest PLPG function that you could ever write. Basically, given an integer, I want to return a column of integers. So let's say that I want to return the input integer is 5, then I probably want 1, 2, 3, 4, 5 return. And let's see how we can do that. So, so this is how we can do that. We can use a for loop to iterate through from 1 to the maximum number. You see that the maximum number is an input parameter, and that is why it has an underscore before it in the very beginning. And for every row, what we do is that we return the next I. So this is very important. You need to be able to fully understand this. So what happens is that the function expects you to return a column of integers, so a set of integers. When you see set of something, it means that you're returning a column of that type. You can be returning a set of beers, then you would have a beer name, beer type, beer price, and then in a column, so basically a table. And if you have a set of integers, then you only have like a column of integers. So when you're using return next something, what you're doing is that you're building up the final result step by step. So when I is 1, it attach 1 to the result. And then when I is 2, it append 2 to the result. And then in the end of the for loop, the result becomes 1, 2, 3, 4, 5. So return next is basically building up the result set. And in the end, this return is actually optional. In the end, upon termination of this function, 1, 2, 3, 4, 5 will be returned. And if you don't, so the good practice is to write return in the end no matter what, to indicate that this is the end of the function. But if you don't do that, and you have already built the intermediate result within the for loop, and you just end it, it will also run. It will be also fine. Let me run the necessary schema and data first. And then let's run this and see what does it do. So the way we use function is that we can select from function. And there are another kind of like a sibling of function, which is a procedure. And you can see the way we treat function. By looking at the way we treat function and procedures, you know what they are. So we're selecting from a function, which means that function is kind of like a parameterized query. So a function is used for queries, and procedure is used for manipulation of data, updating, deleting, inserting, things like that. So we're using a function, so we're selecting from it. So this function has a terrible name, ITO, iota. I think should have come up with a better name. So what it does is that use the for loop to go through from 1 to 4, and then append every number and builds up a column and return it. And let's check if you don't use the return in the end. Let's just drop this function first. I think we don't have to drop it because it says create or replace this function. So a same function with the same function name and the same input parameters, if you want to update it, you can just use create or replace. So it will replace that function definition for you. Let me just replace that, and it should run the same. It should be the same. So without return, it runs the same. And another example is that we can use return set of beers to actually return the beers preferred by a specific drinker. So remember that we built up a view for this. So for John, we built up a view called John's favorite beer, and for somebody else in the database, we also built another view. So if we want to make it parameterized, then we want to make a function. And obviously, John's favorite beer or Jerry's favorite beer could be a bunch of values. So it makes sense to return all of them. And to better understand the structure, let me look at beers. So beers, we got name and a manufacturer. And what else? So we're looking at preferred by it. So we need to look at the likes table. So likes table. So we got drinkers and beers. And this is how we can do it. So before we use functions, we just write a basic select statement, and then we just put John over here, and then it will return John's favorite beer. And there are actually 3 ways of doing this problem, and I'm going to show all of them, and they're all equivalent. And do you understand why I'm showing all of them later? So actually, this example is, let me go back. It's lost here, sorry. So as you can see that this problem is actually pretty easy. We just need a select statement, and then we need to match the input drinker, for instance, John or somebody else, to the likes drinker column, and then we just return the beer's name or beer's attributes. So what we could do is that we could just match it with the input parameter and then be with it. But however, in PLPG function, you cannot just write a SQL statement and be with it. You can, but you cannot return the set of beers like that. So in order to return this, you need to say return query, and after that you write a SQL query which will be returned as a set of beers. So this is the first way of doing it. So this is probably the most straightforward way to do it. So let's just use this function. So this is called select from fav beers. Note that I didn't write beers in uppercase because function names and syntax related SQL code are case insensitive. But John is not case insensitive because John is string literal. So if you want to get John's favorite beer as well as who made the beer, then you use it like this. What it does is that it plugs that into the SQL query, and then it will return the result of that query. So basically, this is the SQL query you're writing, and this is return query. So this is very important because an alternative way we could do this is that we can directly use SQL functions. In SQL functions, we can just get rid of this part, return query, and write a SQL function, and then write a SQL statement over there, and then it will work the same. So this is the example of the SQL function equivalent. So notice the difference. Now the language is SQL instead of PLPG SQL. It returns the same type, which is a set of beers, and then the function body is slightly different this time, because in SQL functions, we are allowed to just use a SQL query. So another twist is that some people like to put language over here, so that is completely fine. So you could specify a language in the beginning or in the end, so they work the same. So let's demonstrate this. So it should have the same behavior as the PLPG function. But in PLPG, we need to add extra return query to make it work. Created another function called favorite beer 2. Let me just do this for John again, and it returns the same beers. And here's the interesting part. So this is a very kind of complicated way to write the same function. So we did the query in PLPG function, we did a query in SQL function, and now we're going back to PLPG SQL again using a for loop. And this is actually kind of like an overkill, but this is but by looking at this, we can understand how for loop works and how return next works. So obviously, what we can do is that we could do a for loop. So R is defined as beers row type. So this is super important. So beers, let's look at beers. To better understand this, you need to look at the beers table. Oh my God, this is too, okay. So beers table, let me do this again. Beers table has two attributes, name and manufacturer. So basically, let me just look at it. Always good to look at the data. So basically, on the left-hand side, we got the beers. On the right-hand side, we got who made the beers. So the beer makers, the manufacturers. And when we define R, we declare R. So notice that R doesn't have an underscore before it. So R is a local variable we'll be using in our function. So R here is a local variable that stores a row of beers. So R, you can think of R as a row of beers, or a record, if you will. And we iterate through this SQL query. So if you run this SQL query, and it will return a table, and then it will go through every row in that table, and then R will represent every row in that table. And then for each row, what we do is that we take that row, put it in our intermediate result that we're building up. And upon termination of that for loop, we're basically copying this table to our final result. And in the end, we return that result to the user. So this is kind of like an overkill. We already got the SQL query, and then we go through every row, we copy that to the intermediate result, and then we return it. The reason why we want to do this is because we want to better understand how row type works, as well as how for loop works with SQL queries. So another way so there are a couple of ways of defining this row type here. So this is actually the preferred way, because you're explicitly saying that, okay, R is is a local variable. I want to use R to store a row in beers. But this is very clear. What you can also do is that you can just define it as beers, and it will also represent a row in beers. And if you're lazy, you can also do record. So we'll use it later to demonstrate. A record is basically a row type in any table. So it will change its shape based on what you give it to it. So if you declare it as a record, it means that it is any tables row type. Let me try record here. So it should have the same effect. Let me replace this function and call favbeer3, and it has the same result. These 4 beers are John's favorite beers. So if you got a record, it works the same as beers row type and works the same as beers. Let me try this. So this is where people often get confused. So I'm showing all options, so you know that they're equivalent. So this is equivalent to row type as well as record. And if you want to be more specific, it is recommended you write beers row type. Okay? And so we talked about this. This is very simple, and we talked about how to return a set of beers preferred by a specific drinker using PLPG SQL function. There are 2 ways, and SQL function is 1 way. And I think it's good. You see that this is where we're defining it as a beers row type, and we tried that. If we drop the row type, it works too, and if you declare the record, it works as well. And let me show you something more interesting, where we're not just copying the table from left to right. We're not just recreating the table. Why do we bother with so the question is, why do we bother with a local variable anyways? The reason why a lot of times we bother with local variable is because we want to apply some more specific post-processing on each row. So if you have ever written any pandas code in Python, there is something called a map. So for each row, you want to map, maybe you want to map your name from uppercase to lowercase, or maybe you want to concatenate your first and last names. So these are the things that are, if the logic gets more complicated, it is not very easy to specify them in simple query, because you ended up with a super long select statement, and it's not very good to read. So the reason why we can do, let me make this larger. The reason why we want to use a row type is because we want to use it in an object-oriented manner to play with beers attribute. So what are beers attribute here? Beers attributes are name and a manufacturer. So what if I change the return type? I just say that I'm going to give it a terrible name, temp, and I'm going to return a set of text. So I'm going to combine those 2 columns. And now I'm still iterating through the same table, but this time for each row, I'm doing something else. I'm making those 2 attributes concatenated together. So what we can do is that we can do it in an object-oriented manner. So let's just return beers names. Let's just call beers names, beer names. So R is representing 1 row in that in a beers table, and then R.name will be a piece of text. So it will be appended to your intermediate result. Let me show you that. Do that, and let me just still use John as in, because I forgot what other names we have. Beer names. Okay. Now it will only return the names of the beers, and of course you can get something more fancier. You can get is made by. You can do string concatenation and made by r.manufacturer. So you can say that you're building a text. The beer is made by a manufacturer. So let's just call it beer info. Okay. Not sure if this works. So this will define this function again. Let's use John as the input, and beer info, it should say that, okay, this beer is made by this manufacturer, and this beer is made by this manufacturer. So imagine if you're doing this, if this piece of logic gets more complicated, then we can't really do that in SQL anymore, and that is why we can do it in PostgreSQL. And following the beers, I think we should, building on the same code base, we can just jump ahead and talk about some things that are interesting. So procedures. So the same the same function, but if we make it a procedure, then the difference between the function and the procedure is that first is the way we use them. We need to use call instead of select. The second is that a procedure does not have a return type. So it does not return anything. It only do something. So maybe it is updating certain tuples in the database, or is printing something for you to read. So this is a helper procedure that we've created demonstration purpose. You can see that it doesn't have a return type, and it doesn't return anything. And the only thing it does is that it raises a notice to the client, and the notice is basically showing the value of the beer. So it's showing that it's showing the value of the beer name instead of returning anything. So if you want to use this procedure, you need to do call this procedure. So so this procedure is called show liked beers. So if you do that, it will give you a notice telling you, okay, the value of this beer name is this text. So that's the slight difference between function and procedure. And the real takeaway is the structure. Like you can actually define a local variable representing a row type in the table, and then iterate the query table. You iterate the result of a query, and then apply some processing to each row of that query. Okay, that's an interesting example that highly recommend you to play with it after class. And let's talk about function overloading. So a function should be identified by its name and parameter types. So basically that's its function signature. And just like other languages, we can also do function overloading. But if you're defining the same, if you're defining the function with the same name as well as the same input type, then it's considered the same function. But if you define a bunch of functions with the same name but different input values, you can overload them. You can they're treated as different functions, and you can actually call them from each other. So this is a pretty easy example. So we can define a function that returns the integer from 1 to n. So basically sequence n, and underscore n is basically the input parameter, and we're gonna build up the result set within the for loop 1, 2, 3, 4, 5, 6, and we can define it like this. And we can also define as something that returns the values between n and m. So we can use a for loop to go through every integer from n to m, and then we can build up that intermediate result, and then we can return that. And we can also make it slightly more complicated. As you can see that we can also define the increment in between. So we can do like 2, 4, 6, 8, 10 with basically with increments of 2. And one thing you notice about this this control flow here is that, do you realize anything strange about this? Because this looks like this looks like a mess to me actually. So the language is quite old, so there's no like easy way to write a for loop with increments. Like in C++ or Python, we can have something like for I in range and then something, and then in C++ we can do for I equals 0, I is less than 100, and then I plus plus. But in here we got to use a while loop to update the incremented I, to increase the value of I, so that it can work like for loops in other languages. But that's okay. The catch is that if we have defined the most general one, we don't have to define these two anymore. We can just basically call them from the, we can basically call them inside of the function body. So if you want, let's just say that this has been defined, we know how to list things in a range with a predefined increment, then we can basically call that function. We can just return the query, and then we can use that function within our new function. And the same with the 2-parameter version. I'm going to quickly demonstrate that because it's very unlikely you actually need that in the near future, but maybe you probably use that in when you go to the workplace, maybe. So let's demonstrate this real quick. So this is a most generalized version, which specifies the starting point, end point, as well as the increments. Select from sequence and just do 2 to 10 with increments of 2. It will do that. And if we want to, after we have defined that, if we want to re-implement this, let me just say, if we want to re-implement this, we don't have to write this again. What we can do is that we can basically return query. Remember that before any select statement, if you want to actually return this select statement as the result, you want to use return query, just like the beers example. So return query, what do? We select from the predefined function. So basically, the starting point is always 1, and then the end point is _n. The increment is just 1. Okay. Let me just do that. And let me check. This should work. From sequence, just do 10. Okay. And I'm not going to demonstrate the 2-parameter version because it's not as interesting. Okay. Here's something that we need to be aware of. We actually have some flexibility in how we output the data. So we have talked about how to return a set of tuples. And the return set can actually be defined in different ways. We can define it on the fly. So basically, in the function body, we can say that we return a table with X attribute, Y attribute, or we can create a type of the table that we want to return. So if there is, like right now, we have been working with the beers table. So it's very easy for us to just write return set of beers. So here is a set of text, and here is a set of beers. And we're able to do this because we already have the table beers defined. It's defined nicely for us. And what if you want to return a set of something that has not been created? The table has not been created for you. Then you can create a type, and then you can return the set of that type. So basically you're defining a tuple type in an ad hoc manner. So if you want to do a pair which is 2 integers, then you can declare that, and then in the end you can return the set of pairs. Or this is what we have done already. So there's already a table, well-defined table with attribute names defined. Then you can just do set of that table name. So we have done a set of beers. Okay, let me demonstrate this real quick. So if you want to create a type of pair, so create a type of pair, and let's just modify. Let's just modify our sequence function so that it returns a pair of values. So let's start with the the easy one. Okay, so create a type like that and demonstrate. So return, this function returns a set of pairs. Okay, give it a different name. So sequence pairs, and the input is just going to be, I'm not going to bother with 2 integers. I'm just going to do 1 integer. So starting from 1 to m. And what we do is that we build. So now, what do we need to do here? So before we're just returning a column of integers, and then the local variable can just be an integer. Now we want to return a set of pair. So we need to say this is a set of pair. I better put that right up here. So this is called user-defined types. Type. User-defined type. So this is a pair which is basically 2 numbers. And before we are doing a column of integers, so with the local variable can just be an integer. Now what we want is that we want I to be to take after a pair. So we can do that, and pair has an x and y, so we need to set I dot x to maybe, let's just give it 1, and then just let y dot y to be I. Just so basically, or we can make it more interesting. Just do I on the left hand side and I times 2 on the right hand side. Okay, and then we can just return the next I. So basically, each pair has 2 attribute x and y, and you declared I as type of pair. So you need to specify what are the x and y coordinates in here. Okay, let me just do that. I'll create a function. So if we input, wait, I did the 2 parameter again. Let me just do 1 parameter. Okay. Okay. Sorry, drop function. Drop function sequence pairs. Okay. I'm going to do it in the 1 parameter version, which is easier. Okay, 1 parameter version. And now we want to use this function, so select from sequence pairs. Let's just do maybe 5. It should give us wrong result type in return next. Think. Oh, so you see the issue here. So I is declared as a pair, but I is also is used as a integer here. So here now we probably need like 2 intermediate local variable here. So we need I to be still need to be the integer, and we need maybe a temp to be actually the pair to representing our instance of pair. So I will still be iterating through the integers, and then we need to modify temps values. So temps x will be 1, and temps y will be 2, and then in the end will be returned the next temp. And the return type is a set of pairs, and then this is a pair, so this should work. Okay, let me do that again. So you might notice that the weird thing about function definition is that one thing that is very annoying about function definition is that when you're creating the function, it will not give you a syntax tag, and it will not say, hey, this went wrong. You will only discover it is wrong when you're actually running the function. Okay, that should work. So this is how you can create user-defined pairs. So you want to make everything in line, you want to use an integer variable to go through the loop, and then you want to define basically a placeholder for the pair, and then you want to construct a pair, and then you want to append it to the intermediate result. Okay, so I'm not going to demonstrate this one because this is rarely used, and we have demonstrated this, and this is actually the most of the times you will ever use, you will ever need to return a set of something, which is when the set of something, the table is already well defined for you. Okay, let me see what other examples we could do. So here we can write a PG function to give a list of beer price pairs. So here we're looking at the good old beers database, and so this is kind of like a summary table that shows you basic information, aggregated information from the database, and just show it to you. So here we didn't use a user-defined type, and we didn't return a set of some already known table. What we're doing is that we're defining the table, we're defining the return type in an ad hoc manner. So basically, we're defining that the table should be of the shape beer and price. So it will have two attributes, beer, which is text, and a number, which is the price. And let me demonstrate how we can do that. Okay. So let me just run that. So basically, we need to we're going through the old pattern here. So here we need to find out the all of the quotes, all of the beer prices in a specific bar, and the input bar is given as _bar. So this is a SQL query, and then we can use a for loop to go through the result set of that query, and then T here is very cleverly written as a record. So this is a lot of times when you don't bother with the row type, you can just say T is a record of something, and then you can use T to iterate through a known table or a result of a query. So in this time here, we're using T to go through every row in that in the result of that query. So this basically gets all of the price, all of the beer price in a given bar. And then what we're doing is that we are assigning the beer's name as well as beer's bars to _beer and _price. So in here, _beer and _price are treated as variables, and we can basically return next, and it will build up the intermediate result for us. And we could do a return in the end, but it is optional. So it is good practice to put return in the end to indicate that this is the end of the function. And notice that this is an object-oriented way of manipulating data. So T here, after we write for T in this select statement, T will be of the shape cells, because this is basically doing a query in cells. And let me look at the structure of cells. So T will be like a row, will just be like a row in cells. So let's just look at cells. Cells has 3 attributes, bar, beer, and price. So basically, T is kind of like, let me think of a good example in C++. It's kind of like a struct or a class. You can think of T as an object, and it has 3 attributes in that class, and then you can use them in an object. So this is kind of like object-oriented programming. You can get name of the beer as well as the price of the beer, and then you can just allocate that to the result table, and then you can just return the intermediary. You can return the result you have been building up after the loop. So let me see if we can use this function. So select from here. So I remember there is a beer called Australia Hotel or something. Australia or Australian, I'm not sure. Australia Hotel, okay. So it grabs every beer and price from Australia Hotel, and then it will put that in this new table. So the reason why and this looks like a lot of work for very little, for a very simple query. And the reason why people would want to do something like that is because if they define the new return type like this, they get to change the column names. So if we just do, if you look at the original sales table, they were probably they're probably different names. And if you just do a normal SQL function or PRPG function, it will take after the original column names. And if you want to give it fancier names, you can do it right here. Okay, this is a good place to take a break for 10 minutes, and we'll come back with more PRPG SQL function examples. This is the beer price.
A question. What happens if you try and drop a function that has been overloaded to the multiple versions of it?
Sometimes it will not get because.
Because drop doesn't.
Do I drop the function?
No, well, drop doesn't take parameters, right? So if you have an overloaded function that has multiple versions, there's one with one parameter and one with two parameters. What happens if you drop it?
I think I'm just trying to play safe because sometimes I got the function names wrong and.
No, but what if you have when you drop a function, you just go drop in the function name, right?
Yeah.
What happens if you have an overloaded function and it has one version with one parameter, one version with two parameters? Which one does it drop? What does it drop?
I think it might drop all of them. I haven't really looked into that.
Okay.
I'll get back to you.
Okay.
I never encountered a scenario like that.
Yeah, I didn't think of it. Yeah. Push the button.
Oh,
I
you're
think
thinking apps and all?
I'm thinking like random notes to like to see.
No, but it's fine. Like, as long as it runs, right? Yeah, so I'll just push them onto the like standard.
And I was like, then I'm gonna have to figure out how to like print it exactly how I'm going to print it. It's auto, yeah, it has an auto.
Yeah. So this is how I was thinking. Yeah, yeah. And you want to print in the sense. Actually, no, I don't know if this works. Because you wanted to print in the order of.
Order of.
Yeah, yeah. Because I want to check the zero first. Yeah, first. Then next one. So, put it in the order. Yeah.
I really like this function.
It's actually not that much shorter. It's 206 now.
Yeah.
So,
Now it's like 217.
yeah, it's the same. Honestly, that's nothing. I started at 1
You need two separate ways.
Yeah, and that's why I was like, wait, shit.
You can control.
Yeah, but will I get to something? I'll go to the astrology this one. And then I realized, no, there's no way. And then I came around and I was like, this is there, right? But it's like, shit. Did I just miss it? And then I realized that, yo, that's shit.
And it's again, it's also stuff. You got some gaps there.
Yeah. It sounds pretty down back there.
Oh,
When's this due?
Doing this assignment, maybe catch up with your lectures.
Yeah.
Because you need to watch all the lectures.
Yeah.
So it's the first day, like, I started on the Friday. Straight 2 hours, I was just watching lectures.
Ah, shit.
Yeah, then what I did was all the texts was I added that distance, almost everything, and then Sunday pretty much finished just random.
是小助理，碰到这种助理就是不反应的这个思维，对，一直看着人搜东西。
Wait, I haven't watched the episode. I need to go to
I didn't really understand this because I just kept on searching for something. But I think
It's pretty short, that's why like, I got so good.
yeah, yeah, fair enough. I think I was just tired of watching stuff, so I was like, no, this is Process.
I love it, it's 30 minutes in this.
Yes, I know, because it feels good. You feel like, oh, that's good.
Because I feel like you got a lot of progress now.
Yeah. But then it's not like a lot. I know, I'm bad, yeah. I hope. Yes, exactly right. Only watch a few of these in the actual trade. Hold on. I don't know. What do you think?
The web page, don't bother with it, it's just JavaScript.
This one?
Yeah, don't bother with it.
Okay.
If you sat through that, that was in 1.2 hour like in person. There's nothing that isn't in here. It's
Alright, fair enough. Then I'll watch a few of these just in case. Like events, I kind of understand.
Events is like that, that's not like, it's just like they look into other stuff like, that's not just so, I mean, well, I thought if you go up with the group guys, it's not like, forms is like, people don't have forms. Yeah, have the form IDs and that can't really form the form.
Right, let's go back to PLTPG functions. So we talked about how to define a row type, and we talked about how to, we have already talked about how to defer the type definition. So we can use record, of course, obviously, and the interesting about this syntax is that most of the times we're defining something and then use it in only one table, but if you have different tables, if you need to process different tables, it will change its shape to accommodate different tables. Okay, let me give you an example of where the record variable can actually change its shape. Okay, this is an interesting one. Let's show this. So if you want to show record with different queries, okay. So in here, we're returning the end result is a set of text. So basically a column of text. And if we want to show information about different table, we can do that, and we can define the local variable as record, and then if the input table name is bears, then we go through the bears table to grab information and print it. If the input table is bars, we go through bars table and aggregate information and print it as well. So let's just test that and have a better understanding of the record, how to define something as a record. So, so if you do bears, oh, I think we have we defined this function yet? Okay, now we have. So info, not infor. So this will go through the beers table and then concatenate beer's name and beer's manufacturer, and then show them as one column of text. And if you put bars in here, the row variable will morph into the shape of bars, and now it will have the bar's name as well as bar's address, and then it will concatenate those information within the function. So now it will show the information about these Australian bars. Okay, so we have seen enough with how to use the record variable, and so basically we have to do a query. We can use a function or a view, and the difference is that for functions they can take in parameters, and for views they're kind of fixed. They're kind of fixed based on the database, and we can't really change anything about a view definition. So let me see if this is worth talking about. Let me talk about this function again, and we'll proceed with the select into syntax. So here, if we want to grab the drinker's name, but we don't want their phone numbers, and we can use this again. We can use that pattern again. We can use a for loop to go through every row in the drinker, and then we can define a local variable called t to take after the value of a row in the drinkers. So let me define this function, and the good thing about, let me see if you remember this. So so t here is defined as drinkers. So what other options do we have? Do you remember what other options do we have? There are two more options. That works the same. So let me just see what this function does. So d1b. So basically, it expects two input parameters. We need a drinker. I'm just going to put John again, and then suburb. Let me see Kingsford. Okay. Syntax error. From. Did I miss the from? Okay. Okay. So Kingsford is not found. Let me check what are the legitimate. Randwick. Okay, let me try Randwick. Randwick is a good one. Randwick. Wait. No function. Did I define it? Okay. No function matching. You need to add explicit type D1B. Let me define it again. Okay, this is weird. D1B. So it says the function does not exist from drinkers. Let me see. So basically, what I was trying to get at is that T is kind of a placeholder for a row in drinkers. So we could have written drinkers row type, or we could have written T. What have we just talked about? Record. Yeah. So record will take after any tables row, but these are more explicit ways of. Let me see if I've. These are more explicit ways of defining the placeholder local variable. Let me see if we have defined this function already. Oh, okay. We defined this table already, so that's fine. And why is this function not getting created? Okay. Can anybody see why this is not working? From D1B, did I type it correctly? And oh, okay. So this thing doesn't have. So I was mistaken. So this thing doesn't have a input parameter. This is only taking in nothing, and it returns some It returns some summary text for you. So basically, it will look at the drinkers table. So before we have drinkers table, we have 3 columns, and now it says that we don't want the phone number of the drinkers anymore. We're only grabbing the name and the address, and we're changing them into drinker as well as suburb. So this is how we do it. We map the row name into drinker, and we map the row's address into suburb, and then we don't do anything about their phone number. And then in this way, we can iteratively build up the intermediate result, and in the end, we can do a return. And this is optional, and it will basically get the same table without the phone number for you. So so this is equivalent. So the point I'm trying to make is that this is equivalent to drinkers row type, and this is also equivalent to the record. So I'm going to comment them out. Okay, so basically this pattern is super important for you to. This is super important for problem solving in PLPG functions. And there's one element missing, which is now we can actually apply some complicated logic for each row, but in procedural language, what we are able to do is that we can actually store something as a variable and then play with that variable. So this is super important. Select into syntax. So basically, this kind of bridges the SQL language with the procedural component of PLPG SQL. So select something is basically returning a query result. It's kind of like a table. And then select something into a variable. We can store the query result into a variable. And the expected behavior is that if you do one select statement into a tuple, it will store the first tuple in that table. If we want to work with every tuple, we need to use a for loop. So let's look at some examples. So this is kind of like an imaginary table. Let's look at R and so this is a table with 3 attributes, A and B and C, and we need to write a couple of PLPG functions where select into is used. Let's look at the schema of this table and see. So this is R. This is R. R has 3 attributes, A and B and C. And if we want to collect individual attributes into variables, this is how we can do it. So basically, let me look at this. So this is the first function that we want. So this is the select into clause. So here, if you get rid of into, select something from R where A is 2. This is basically a so this part is a classic select from where block. This is just a SQL query. And the only thing that is added here is basically selecting those attributes into some local variables. And if we're doing that, it will take after the first row in the result. So if you do select ABC from R where A is 2, let's see what it does. So if you select A, B, and C from R, or R, where A is 2, it has 1 row, so basically A gets mapped to X, B gets mapped to Y, and then 1.2 gets mapped to Z. And if you have multiple rows like this, it will take the first row and then map that to X, Y, Z. So to make it more clear, so this returns a set of new set of X, Y, Z. So I just run this and select from S1, and note that X1 doesn't have any input parameters. I made a mistake before. And it will take after that specifically matched row. So what if I get rid of where A is 2? And so what do you think will happen if I get rid of A equals 2? And so these are the tuples in R. If I get rid of the filtering condition, it should get the same. It should get the first row in this query. So if we just replace that, and if we run it again, yeah, it should get the first row in that query. So first row is 1A and 1.1. Yeah, 1A and 1.1. So that's the expected behavior. And let's look at how to handle missing data. And remember in the beginning of the lecture, we talked about there are 3 ways of getting someone's favorite beer. So we talked about how to use a simple SQL function. So in the SQL function, SQL function, we write a select statement. And in the PLPG SQL function, we write return query and then select statement. But in PLPG SQL function, if we just write a select statement and if we don't put return query before it, after that we can actually see whether the query went through or not using the found variable. So this is kind of like a hidden variable you could use to check whether the match has been made. So here, for instance, you can select that into a tuple, and this tuple will take after the first match, and after that you can check whether this match has been made. If there's nothing matching this criteria, then you can handle that you can handle that case in not found, and otherwise you can do it, you can proceed with some other logic. And another way we can use something like select into is we can see how many rows are matched. So we can do select, count everything from the table where we apply some filtering conditions, and then we can map that number into the number of matches, and then we can do an if statement on the number of matches. So basically, if the number of matches is 0, then it's basically the same as no match. And if the number of matches is 1 or 2 or 3, then we can proceed with different logic. So let's take a look of these examples. Okay, how to handle missing data. So in the first example, we want to play with the a company's database. So here we have an we have an employees database. So employees, we have each person's tax file number, the name, as well as the salary. And basically, given a name, we want to extract the TFN of the person. So I can imagine why HR needs a function like that. A lot of times they're sending us like all kinds of emails about like, what's your TFN? We need to update your text status. So let's look at who are in this database. So we got Alice, Bob, Charlie, David, and Emma. And what we want is that we want, given the name Alice, we want to get the tax file number a bunch of ones. So these are, of course, made up data. So what you want to do is that you want to have some control when the person's name is not found, and then you cannot really return a legitimate TFN. So what you can do is that you can select the TFN into a local variable. So basically, you can just do a query right over there. And after the query, you can check whether the match has been made. So here, if it's not found is basically saying that we could not find a match where we match the name and then we want to put the tax file number into the variable. So this has failed. If this has failed, we can just return no such employee. And if this is actually found, we can return the actual tax file number. So let's just try this. And so if we put some random person's name, then this will not really work. So if you put Alice in here, okay, always forgot from. So if I just don't put that, I can. So for functions, you can do select from functions, or you can do select function. Both are equivalent. So for Alice, we were able to get Alice's tax file number. And let me see something, let me see, Bob, no. And I think my name is not in the database. So if I put Jerry in here, it will say, hey, no such employee. Okay. So this is another way where you can use that. Let me see if we can demonstrate the number of matches. So let me first check whether this is a good database to do that. Well, probably not a very good database to do that because we only have like 5 people. Let me see if we can do that on some other database. So basically, we demonstrated this function. We can do a select statement right here, and then after that, we can check whether the match has been made or not. Now, let's look at another example database. So this is actually the previous term's assignment database. So we have changed that, obviously. Now we're using football. We've been using cheese for so many years, and we had to change it because before people figure it out. So this is a cheese database. We got 4 entities. We got places where the cheese makers are located in. We got different styles of cheese, and we got the makers of cheese, and we got cheeses themselves. So we got 4 entities. And we don't make additional tables for the relationships because they're all one-to-many relationship. So basically, we're storing the foreign key in one of the table so that we don't have to create a new table. So we only got 4 tables in here. So don't worry if you don't know where to find this code. We'll release this demonstration code after class. So these are the table definitions. So every table has a primary key indicated by their ID. So we got places, they got ID. Table, they got makers, they got their ID. Styles, so all of the IDs are primary keys. And notice here, they are declaring the foreign keys in this way instead of in the end. This is fine as well. So notice that we're not saying, hey, foreign key something references styles ID. We're just declaring it in line. We're just saying that style is not null, and also style references another table's primary key, which is styles ID. And then made by is doing the same. It references maker's ID, so it's the primary key of makers. Okay, so what we want to do now is that we want to write a PLPG SQL function on the cheese database. So we want to add a tuple to the cheese, and we want to link it to the appropriate makers and the styles entry. And we want to raise a notice if the maker or the style doesn't exist. So you can imagine this requires a lot of thought, and this is exactly the scenario where a simple SQL function will not work, because SQL function can only give you different tables, slicing tables, joining tables, but they cannot really check. Well, they could check, but they cannot do things like step by step in one function and store variables and then use for loops. And in the end, we want to return the ID of the new cheese. So let me look at how we can do this. So one thing you should always remember is that when it comes to functions, we have 2 types of functions, the PLPG SQL functions as well as SQL functions. And if ever we ask you to write a function and we don't say what type of function we want, you can do either. But if in the exam or in the assignment we specifically say that, hey, we want a SQL function for this, then you have to write a SQL function. So obviously SQL functions are easier to write, and PLPG SQL functions are more powerful. Okay, let's look at these tables for a bit. So we got the cheese table. Let me look at how many cheese we got. We got we got like 10 cheese. Let me just look at first 4. And we also got the makers table. So before, what? Let me see the table. Okay, I need to reload it. This is fine. Okay. Let's look at the makers table. Got 10 makers, and we got the styles. How many styles? I didn't know there are many styles of cheese. We got 10 styles. Cheddar, Wisconsin. I'm surprised mozzarella is not here. And what other tables that are, places? Okay, so places. Places. So we got 10 places. Oh, I didn't know China has cheese as well. So we got 10 places that make cheese, and got France, Italy, Switzerland, great. Okay, so now what we want is that we want to add a tuple to cheese for the new cheese. So why do we need like a whole function for that? Can you think about why do we need a whole function to do it? So by thinking about it, you can kind of understand the logic of the add cheese function we are going to implement. So when we want to insert, and this kind of links to what we'll talk about on Thursday, which is triggers. So when you add a tuple, when you initially populate a database, everything is done very nicely. You see a bunch of insert 0, 1s. But afterwards, if you want to add a new tuple, if you want to add a new set of tuples to the database to satisfy some constraints, then what are the things that you need to be aware of? So here we want to add a tuple to cheese. So whenever you want to do that, let's look at cheese table. So cheese has a primary key, the ID obviously, and it has here, so I really like this command. It gives me everything I need about the table. So also 2 foreign keys. So we need to know who made the cheese as well as the style of the cheese. And when you're inserting a new tuple in this table, what do you need to check? So this is kind of like, what foreign keys? So like more specific. And, yeah, and what else do you need to check? Pardon? Yeah, you're almost there. So unique is like half right, but you know. So what else do you need to check? So basically, yeah, you're right. You need to check both the foreign keys as well as primary keys. So when you insert a new tuple, you need to first check whether you're inserting an ID that is already there. So that's the most important part. And then after that, what you also need to check is when you enter the fields made by as well as style. You need to make sure that those are existing styles and those are existing makers. So if you try to insert, let me try to insert some random, let me see what cheese does. Select from cheese. So cheese has already 10 rows. And what if I want to insert into cheese, cheese or cheeses? I think is cheeses. What if I want to insert into cheeses and values are, I'm just going to put 2 over here, and I'm going to put name is basically, this is a random cheese. And do you think this will work? I'm just going to meet the other ones. So what's wrong with this query based on what we have seen? The cheese probably doesn't exist, but is that a problem? If, the cheese doesn't exist, it's fine because we're inserting a new cheese. But what happens if the style doesn't exist, right? If we just put like random style cheese. Or we can just put it 3311 style. There's there's no cheese with this style. And for aged full, we can just leave the other ones as default values. So if we do this, what is the first thing you notice that has a problem? The first value, right? Yeah, because we already have a cheese with ID 2. So if you do that, it will violate select cheeses. Okay, this is a terrible view. Let me see. We can make this wider. Okay, I'm sure this happens a lot when you're using, okay, this is better. So we already have like IDs from 1 to 10. So if you want to insert a cheese with ID of 2, it's kind of like adding a new student with the same ZID. So it will violate the primary key constraint. So that's the first thing we look for. And the second and third thing we look for is that if you are inserting a style, so a style is a number, if inserting a style like 100, and the style doesn't exist, that's a violation, that's a referential integrity violation. And if we add a maker, maybe we say add a maker 99, then that maker is not found in the makers table, then that's another violation. So when we are adding a tuple into the database, there are a couple of things we need to be aware of. The first thing is that the primary key constraint must not be violated, and then those two referential integrity cannot be violated. So basically, the foreign key constraints cannot be violated, and that brings us to our add cheese. Let me see, cheese function. So. Okay. So the input is, God, I should not try to press that again. Okay. So the input are basically the name, the maker, the style, and aging is kind of like an integer, and maybe this is percentage of fat. And these are input parameters, and they're preceded with the underscore. And we need to declare a couple of integers to go through 3 tables individually. So these integers are needed to store some IDs. So first, we need to find the maker of. First, we need to check whether this maker exists. So let's go to the makers table, and then we can select ID into makers ID. So just like that, if it's not found, we need to raise a note, hey, this is bad, there's no such cheese maker, and then we should return nothing. And second, we need to check whether the style is a legitimate style. So basically, it goes to the styles table and check whether the style ID is there. So it's trying to match the name with an existing style, and is going to find this ID. And if this style is not found, then this is a problem as well. This is also a violation. This is a violation. This is another violation of referential integrity. And if all of these are good, what we can do is that we're not really inserting a new ID in here because we're just going to make a new ID. So first we're going to compute the maximum ID we already have, and then we're going to add 1 to it. So basically the ID will be self-incrementing if we keep doing that. And we're generating a new ID which is larger than all existing IDs. And in the end, only then we applied insert. So we insert values with the correct ID, name, style, and all other attributes. And in the end, we return the cheese ID. Let me see how it works. Also, for these 2 if statements, what do you think about these 2 if statements? Do you think these are well written? So if it's not found, we raise a notice saying, hey, so no such cheesemaker. And if the style is not found, we raise a notice, hey, no such style. And it returns no. So what does it do? So in the end, it returns an integer. What it does is that it prints, so raise notice is kind of our go-to method of printing messages to the client. So whenever you want to print something for debugging purpose, you can do raise notice. But in practice, when something as serious as this has happened, what we want to do is we want to raise an exception, or we want to raise an error so that it stops right there. And it does stop here because it returns a null integer to the final result. So this is okay for this example, but in practice we probably need something more serious than that. And if you raise a notice from the view of the database, this is not a huge issue. We need to let the database know that this this is a huge issue. So let's see this real quick, and let's do a test chatter. So the test chatter works because it is from an existing maker, and it is from an existing style, and in the end it returns the new cheese ID of it. And if you success, it will give you an ID of 11. And if you do a fake cheese, so basically this is an unknown maker, this is an unknown style, then it will give you a notice, no such cheese maker. So now we can actually control whether a query goes through or not. So we're not going to always do the update in the end. We're going to check a few things before we do the final update. So this, you can imagine this is very important in serious databases like banks or like your broker, your like stock brokerages account, where you need kind of like a unique a unit work, like a transaction, where you want everything to go through or nothing. Then you want to wrap this logic into a function, and then the PostgreSQL will treat it as a transaction, and it will apply everything in here, or it will apply nothing in here. It will not stop in the middle and say, hey, I inserted a new cheese, but I didn't return the new cheese ID. And so this for cheese, this is not a huge issue, but for like banking's database, this becomes much more important. Okay, that's enough with the add cheese function. And in the end, let's talk about dynamic queries. So sometimes this is kind of quite a weird way of running SQL queries within PLPG functions. So basically what it does is that you're preparing a string inside of PLPG SQL, and then you're treating that string as a piece of code and execute it. So it's kind of like you're writing code when you're writing code. So you're preparing the SQL string, and then you're executing it. So so that brings us to quote literal and quote identifier. So when you are preparing a string like this, and if you don't use quote identifier and quote literal, it is prone to security risks like SQL injection. Because right now, if we don't use quote literal, then you need to write like a double quote to escape the single quote from the outside, so that later when the SQL string gets actually evaluated, it will actually go through. So this thing will become this string, and this string will get evaluated in the end. So it gets evaluated using the syntax, let me see, evaluate. So basically it will be evaluated in the end. Let me find the real example of this. Okay, here it is. So let's look at this table. So this is the string that you prepare, and in the end you can execute this query, and then you can store that result into a local variable, and in the end you can return the value of that local variable. So all it does is that it helps you to prepare a SQL string that can be later executed within the SQL function. And the good thing about quote identifier and quote literal is that quote identifier is wrapped around the table names, and quote literal is wrapped around like string literals. If we don't do that, it is very prone to SQL injection, And let me give you an example of that. So, so basically, if we don't do quote literal, what they can do is that if we allow users to put anything in this string, they can do a semicolon, and then in the SQL database, it will basically start a new SQL statement. It will close current SQL statement. It will start a new one, and then you can basically drop all tables. So that has happened a lot before they came up with this. So I think if you work with database, you should know the concept of SQL injection. So these create two pillars of safety. It makes sure that the input is a table name, and this ensures that the input is a string literal. And you probably won't get to use this that much. So if you don't use that, people could do something like semicolon, drop all tables, and then that can actually go through. Okay. I think we should do at least one example of this. So, so this is a dynamic query where you're preparing a string within PLPG function, and then you're evaluating that string in the end. So what is the function name and number of tuples? Table name, I'm just going to put maybe bars, and then it will give me the number of bars in that table. So, or I'll put beers, it will give me 18. So it will build a SQL query based on my input table name, and then in the end, it will evaluate that query, and then it will store that into the local variable n. Okay, so you probably won't use that in your assignment. These are very useful for writing helper functions, like you want to know how many tuples in each table, or if you want to write some generic functions for all tables, and then you can do something like this, and you want to make sure that the code identifier is wrapped around that table name, then you're pretty safe. Okay, that's enough with dynamic queries. And exceptions. So exceptions, we need to handle exceptions in all programming languages. And the good thing about PostgreSQL is that it has a bunch of names for unexpected situations. So we got division by 0, we got duplicate key insertion, we got foreign key violation. So basically this is a primary key violation, this is a foreign key violation, and we got other types as well. So let's look at the division by 0 exception. So if you want to divide something, if you want to divide an integer by another integer, of course you need to check whether for dividing m by m, you need to check whether m is 0 or not. If it's 0, then of course this is not defined. So what you can do is that you don't have to check that in advance. You can catch the error later. So here you can just basically return the division, and then if m is 0, it will throw an exception, and then division by 0 variable will be marked as true, and you can probably raise a notice. You can probably raise a notice here as well. You can raise a notice. Hey, don't divide by 0. Okay, and semicolon. So if you do that, and if we do a normal division, it should not be a problem. I'm just going to divide 4 by 2. Okay, what if I divide 5 by 2? 5 by 2. still 2. They're doing integer divisions. What if I divide 5 by 0? Now it will give me a notice, hey, don't divide by 0. And this is an exception that has been caught. Okay? And so debugging is the last thing we need to talk about. We also need to talk about the other exceptions that we could encounter. So there are invalid text representation. So if you cast a string into an integer, it will throw that error. If it says numeric value, you can also check whether numbers are too large or too small. And so basically, after the exception, you can just change that status variable in here. So you can do, when this happens, then raise a notice, don't divide by 0. When this happens, when numeric value out of range, raise a notice says, hey, attribute something is out of range. And in the end, you want to return no. Okay. Most of the times, I can imagine you using division by 0 if you're computing the average of something in your assignment. And our database are not super large, so you don't have to worry about like numbers getting too large and getting overflow or something like that. And so this is how you can handle multiple exceptions. So when the unique violation is true, you'll say that this drinker already exists. When not null violation is true, then you're saying that you need to say that you need to print that these attributes cannot be empty. And when all others, you can just say that unexpected error happened. So basically, it allows a way for you to catch errors in different categories. And finally, let's talk about debugging in PostgreSQL. I think we have already done quite a bit when we're showing these examples. So the most important thing you need to know is to use the raise notice statement. So raise notice prints, raise notice is kind of like the print statement in other programming languages, and is the starting point when you want to find out why your program does not work. So you could print a simple message like reached line something, or you can print some specific values. So here you can say that I want to print the result of, I want to print the value of x and y at this point. Then what you can do is that you can use a percentage sign as a placeholder, and then you can just print them like that. Okay, let me try this. Okay, did I copy that or? Okay, great. I'm so glad I'm using this interface instead of the CSE VLab gateway, which does not allow me to copy into anything. Okay, so what is that function called? Denominator debug. So I'm just going to do select from denominator debug. I'm going to put 10. And it will tell me the input value is 10, and then y at that time is 20. And in the end, 10 is added to y, and in the end, we return 30. So basically, raise notice is kind of like the print statements in other programming languages in C++ or in Python, which allows you to see the internal state of the program. Okay, that's it for today's lecture. If you got any questions, I'll stick around to do a Q&A. But I got to do it quick because I have a meeting soon. Is everybody happy with the assignment setup? Because I've seen on the forum some people have like issues setting it up. So if you do have an issue, please go to one of the help sessions or go to any tutorial in the week, during the week. So basically, you don't always have to go to the tutorial that you're assigned. you can literally go to any tutorial.
Thank you.
Right.